Welcome to the deep dive. We take complex information, stacks of it sometimes, and, well, we get you informed fast. Today, we're diving into something I think is pretty remarkable, tapping into that universal wish to see our drawings spring to life. Especially those really quirky, imaginative ones from when we were kids, the stick figure with weird arms or maybe legs coming out of its head. What if you could just, click and make it dance? That's basically what we're exploring today. Our deep dive is centered on this really groundbreaking research paper. It's from some heavy hitters: Meta AI, Tencent America, MIT, Carnegie Mellon.
Wicked, the gig names.
Exactly. And the paper's called A Method for Animating Children's Drawings of the Human Figure.
And the key thing is, this isn't just theory, right?
Not at all. It led to a hugely successful public demo, and they built this enormous, unique data set along the way. So our mission today, basically give you the shortcut, understand how this tech works, why kids' drawings are such a fascinating challenge for AI, and, what it might mean for creativity down the road.
Okay, let's unpack the core magic here. You've definitely seen a child's drawing, right? Maybe a person with arms sticking right out of their head.
Oh, yeah, legs that just sort of float near the body.
Exactly. Now, picture just snapping a photo of that, and
Uh,
boom, instantly you see it dancing or waving. That's really the essence of what this system can do.
And it's designed specifically for that variety, that abstract nature you get with kids' drawings. It's fast, it's intuitive.
Yeah, and that public demo they launched, the animated drawings demo, back in December 2021, it just exploded. Millions of people jumped on it globally.
That really shows the impact, doesn't it? That immediate connection people felt.
Absolutely. It highlights just how much people wanted this. And think about the traditional way. Animating even a simple drawing usually takes, well, a ton of skill, right? And complex software, lots of time.
Oh, yeah, hours and hours, frame by frame sometimes.
Right. So this system automates that whole process, which, like you said, is perfect for kids seeing their own creations move. It just wasn't accessible like this before.
So, okay, we get the magic, the appeal, but how does it actually work? How does a static drawing become, a little moving character?
Okay. Under the hood, it's this clever four-stage pipeline. It uses existing computer vision models, but, and this is key, they've been fine-tuned like crazy for children's art specifically.
Fine-tuned because kids' drawings are so different from photos.
Exactly. So stage one, figure detection. The system first has to find the human figure, draw a tight box around it, even if it's on cluttered paper or part of a bigger scene.
How does it do that?
They use something called Mask RCNN. It's an AI model that's pretty good at finding objects and outlining them precisely. But here's the catch.
It didn't work well out of the box.
Not at all. The standard models, trained on photos, they were basically useless on these drawings. They needed extensive retraining, teaching them what a person looks like in this very different style.
Okay, so it finds the figure. What's next?
Stage two is segmentation masking. This means separating the pixels of the figure from the background pixels cleanly.
Sounds simple, but I bet it's not.
It's surprisingly tough. Think about the variety: crayon, marker, pencil, different paper, shadows, photo quality, texture, and color cues, which models usually rely on. They're just not consistent in drawings.
So the AI gets confused.
It can, yeah. So for this part, they actually found that mask RCNN segmentation wasn't accurate enough for good animation. Instead, they used more classical image processing techniques.
Like what?
Things like adaptive thresholding, morphological closing and dilating, flood filling. Think of it like smart digital tools to fill gaps in outlines, smooth edges, connect separate parts, basically make sure it sees one solid figure.
Okay. And does that always work?
Not always. That's a common failure point. If the outline is really broken or parts are drawn totally separately, it can struggle.
Gotcha. So figure detected, separated. What's stage three?
Stage three, pose estimation and rigging. Here, it identifies key joints on the figure, specifically 17 standard points like shoulders, elbows, hips, the nose. They use the MSCosio standard set.
But how, if the drawings are so abstract, a line could be an arm or just a line?
Exactly. That's the challenge. It has to infer the structure even when it's super minimal or ambiguous. Once it locates those key points, it builds a digital skeleton, a rig, over the drawing, like puppet strings almost.
Okay, makes sense. And the final step, animation.
Yep. Stage four, animation. This is where they take motion capture data, recordings of real people moving, and apply that motion to the digital skeleton, the rig.
How do they make that look right on a flat drawing?
They use a technique called as rigid as possible shape manipulation, or ARAP. It basically lets the parts move and bend sort of realistically without squashing or stretching in weird ways. But here's a really crucial design choice, getting back to understanding kids' art. They deliberately decided not to use foreshortening in the animation.
Ah, foreshortening, like when an arm coming towards you looks shorter.
Exactly. Kids rarely draw that way. So forcing it in the animation would look wrong, unnatural for the style.
Yeah, okay. That is a key insight. So no foreshortening. You also mentioned something about twisted perspective. How does that fit in?
Right. That leads to this really neat technique they developed, twisted perspective retargeting.
Twisted perspective. That's like head facing forwards, feet pointing sideways.
Precisely. It's not anatomically correct, but kids do it to make each part as clear as possible.
Yeah.
So the system actually mimics this. It projects the upper body motion onto one 2D plane and the lower body onto another, based on the animation.
So it intentionally keeps that sort of flat look, but animates the parts independently.
Kind of, yeah. It respects the child's representational style. And interestingly, their studies found people actually preferred these animations, especially for big movements. They felt more natural, more in tune with the drawing itself.
That's fascinating. It's not just about making it move, but making it move like the drawing.
Exactly. It respects the source material's unique style.
So stepping back a bit.
Yeah.
What does all this tech tell us about, well, children's art itself and maybe the psychology behind it?
It connects deeply with what we know from child art analysis. Drawings of people. Often one of the very first things kids draw.
Right. You see those scribbles evolve.
Yeah, from scribbles to tadpole figures,
Mhm.
just head legs, basically. Then more transitional forms and eventually more conventional figures.
And the variation must be huge.
Oh, immense. Heads, legs, eyes, almost always there. But torsos, arms, hands, feet, especially in 4 to 6-year-olds, they're often just missing.
Uh-huh. Yeah, I've seen those.
And they get so creative, adding non-human parts, big ears for a cat character, maybe a crown on a pineapple person. It's wonderfully imaginative.
So the system has to handle all that randomness.
It tries to, yes.
Yeah.
And kids tend to use what are called object-centered descriptions. They draw the idea of the object flatly, a circle for a head, a long rectangle for a leg, not how it looks from one specific viewpoint.
Nice leads back to.
The lack of foreshortening and that common use of twisted perspective, these aren't mistakes the AI should fix. They're core stylistic elements. The AI is designed to work with them.
And that really sets it apart from older animation methods, doesn't it?
Absolutely. Many older tools needed lots of help. You had to mark the joints, maybe draw multiple poses, or they were built for more realistic styles.
Right.
This system tackles that abstract, varied, in-the-wild nature of kids' drawings from just one picture. That's a big leap for accessibility.
A huge leap.
Yeah, but, one of the major roadblocks they hit was data. There just weren't big data sets of children's drawings, especially not annotated ones needed for AI training.
So they had to build their own.
They did, which led to the amateur drawings data set, a first-of-its-kind thing.
Okay, I have to ask. How on earth do you collect 178,000 drawings? That sounds like a monumental task. Did they hire an army of kids?
Uh-huh. No, something much cleverer. They use what they call a bootstrapping approach. The data came from the public animated drawings demo website itself.
Wait, really?
Yeah.
From the users?
Yep. When people uploaded their drawings to animate them, they could consent to have the images and their annotations used for research. So millions of people having fun were simultaneously building this massive data set.
That is genuinely brilliant. Talk about real-world data.
Exactly. Real data from our target domain, as they put it.
There's always a but.
Well, yeah, this user-generated data was, understandably, pretty noisy. Lots of variation, maybe not perfect annotations.
So they had to clean it up.
Right, a crucial refinement step. First, they used an AI technique, cluster-based filtering, basically to automatically sort images and weed out stuff that clearly wasn't a kid's drawing of a person.
Like photos of pets or...
Photos of pets, real people, anime characters, company logos, duplicates, all that got filtered out initially.
Okay.
Then they had a contracted agency manually review a big chunk of the remaining images. They checked, is it freehand? Is it a physical drawing? Is it a full-bodied human figure? Does it have copyrighted stuff or personal info or anything inappropriate?
And did they end up excluding a lot?
Quite a bit. They mentioned figures like maybe 30% weren't actually freehand drawings, 20% had personally identifiable information, 15% used protected IP. So yeah, cleaning was essential.
Wow. That data story is really something. It makes you wonder, how much data do you need? And does it have to be perfectly clean? What did their experiments show about that?
That's a great question. And their results were super interesting. First off, using AI models trained only on real photos. Terrible results for drawings. Just didn't translate.
Like teaching Spanish using only French textbooks.
Pretty much. But then they fine-tuned those models with even a small amount of clean drawing data, say, just 2,500 examples, and boom, accuracy shot way up.
So a little bit of the right kind of data makes a huge difference.
A massive difference. Adding more clean data helped further, but the gains started to level off,
Huh.
diminishing returns.
Okay.
But here's the twist. They also tried training with the entire huge, noisy dataset, nearly 180,000 images.
Better results.
Yes and no. It actually improved the pose estimation finding the joints, but it made the segmentation separating the figure from the background worse.
Worse. Why would more data make it worse?
Their theory is that users, when asked to help annotate the segmentation masks, often didn't do it very precisely, especially for tricky drawings.
Hmm.
It's a harder task. So the extra data was noisy in a way that confused the model for that specific task.
I see. So data quality really matters, maybe even more than quantity for some things.
It seems so, especially for complex tasks like segmentation, which, they confirmed, remains the hardest part. Even their best AI model for segmentation only got it right about 25% of the time.
25%, that's low.
Yeah, it is. Their other method, the image processing one, did better, around 42%, but still, it means that overall, only about 39.4% of drawings could be animated fully automatically, start to finish, with no manual tweaks needed.
Less than half.
Yeah, it really highlights how complex this is, and honestly, where human help or, user guidance is still super valuable. It's not quite magic button for everything yet.
That's a really important reality check. But even with that, the public response was phenomenal. You said 3.2 million users, 24 million animations.
Incredible numbers. It clearly struck a chord.
So summing up the effectiveness,
Right.
fine-tuning is vital, segmentation is the big hurdle, but that twisted perspective idea, that was a winner.
Absolutely. Users consistently preferred it in studies, especially for those side-on movements. It showed they really understood the art side of it, not just the tech.
Okay, so looking ahead, where does this go? What's next for animating our doodles, and what are the current roadblocks?
Well, they definitely identified areas for improvement. Better segmentation is top of the list. Still tricky with shadows, lined papers, stick figures, limbs touching.
Yeah, all those real-world drawing issues.
Right. Then extracting more meaning from the drawing. Could the AI figure out if it's a robot, or a monster, or a snowman?
Ah, so it could tailor the animation, make a monster stomp, or...
Exactly. Or remove legs for a snowman animation, make it smarter about the character.
Cool idea.
And they mentioned lots of user requests, too. More types of motion, maybe letting users create custom moves, animating faces smiling, blinking support for animals, multiple characters, maybe even using the background scene somehow. Lots of possibilities.
But there are limits right now, too.
Definitely. Certain 3D motions don't translate well to flat 2D animation. Those complex carving motions lose something. The system also just animates left to right currently. Figuring out which way the character should face is still tricky. And, as we discussed, it's built for drawings without proper perspective. If someone draws with perfect foreshortening, the animation style might actually clash a bit. It's tailored to that specific common child art style.
So it's really, like they said, a first step, a really impressive first step towards a bigger system for drawing to animation storytelling.
Yeah, and it clearly shows people want these kinds of tools.
Yeah.
There's a huge appetite for building on our own creativity like this.
It's been quite the journey today, hasn't it? From, that simple childhood wish to seeing this complex AI system actually making it happen.
Empowered by millions of drawings from people all over the world, that collaborative aspect is pretty amazing too.
It really is.
And I think beyond just the tech, this project really shines a light on that fundamental human drive to draw, to create, to express ourselves. And it shows how technology, when it's thoughtful, can actually amplify and celebrate that rather than replace it.
That's a great way to put it. It connects the artist and the animation so directly. So here's a thought to leave you with. The next time you see one of those fantastic children's drawings, maybe that character with the head facing forward and the feet pointing sideways, what possibilities do you imagine? How else could we bring that creativity to life, maybe beyond just animation, into whole new interactive stories?